Hi, and welcome back to Backer Breaks It Down. In this episode, we continue to work with volume of pyramids and cones. So just to remind you, volume of a pyramid can be found by calculating 1/3 area of the base times the height. Volume of a cone can be found the same way. Since the base is a circle, we can be a little bit more specific. We can say the volume is equal to 1/3 pi r squared times h. In these two problems here, there is a dimension missing. I actually know the volume of the pyramid, I know the volume of the cone, but there's something that I don't know. And in number 3, it's the height of the triangular pyramid. Okay. So I'm working with the pyramid. I know I can go volume is 1/3 area of the base times height. I don't know the height. Right? That's what I want to find, which means that I must know the area of the base. Okay, so whenever we're working with formulas, my advice is formula, substitution, solution. So write down the formula that you're going to be using. That's the formula part. Next comes substitution. So you want to substitute in everything you know. Like I know the volume is 24 cubic meters. And then I've got the 1/3. And then it says area of the base. Well, I know the base is a triangle. I know that you can find the area of a triangle by going half the triangle's base times the triangle's height. So in this problem, the base would be 6 and the triangle's height would be 3. So that means big B, area of the base, is going to be equal to 1/2 of 6 times 3. Okay, so half of 6 is 3 times 3 is 9. So that's the area of my base. I'm going to plug that into my formula up here. So I have 24 is equal to 1/3 times 9 times h. Now I can do two things here. Well, one of two things. I can undo multiplication by 1/3, or I can actually combine 1/3 times 9. That choice is yours to make. I think it's really easy to go 1/3 times 9. 1/3 times 9 is simply 3. Divide both sides by 3, you get a height of 8 meters. Okay, so formula, substitution, solution. Perfect approach to these kind of problems where you're missing one of those inside variables. So in number 4, we're working with a cone. It says find the radius of a cone. Well, I know that the volume of a cone is equal to 1/3 pi r squared times h. So that's my formula. So now I'm going to substitute in what I know. I know the volume of this cone is 351 pi. So I'm going to plug that in. 351 pi is equal to 1/3 times pi times the radius squared. I don't know that. Times h, and h is 13. Can I fit it? Just barely. So I have 351 pi equals 1/3 pi r squared times 13. That looks like really messy. I think I'm going to rewrite it. Okay. So what do you notice about the two sides of this equation here? Yeah, I do too. There's a pi on both sides. So if I go and divide both sides by pi, those pi's are just going to completely cancel out. Okay. Now in this problem, me taking 1/3 of 13 is not as nice as me taking 1/3 of 9. So here's something you can do to deal with that 1/3. You could multiply both sides by 3. So multiply by 3 on the left, multiply by 3 on the right. And what that's going to do is it's going to cancel out the 1/3 because 3 times 1/3 is 1. Okay. So that gets rid of your fraction, multiplying both sides by 3. So now we have, let's see, 1053 is equal to r squared. That's weird. times 13. So to get r squared all by itself, we would need to divide both sides by 13. Okay, so if I take 1053 and divide by 13, I believe I get 81. So 81 is equal to r squared. We take the square root of both sides. We get that 9 is equal to r. So that's our radius. And that's the units are in inches. Okay, so we can totally use these formulas to find a missing dimension in these figures. Just go with the approach, formula, substitution, solution. It helps. So that's how we find and work with volume of a cone and volume of a pyramid. Both of these can be found by going 1/3 area of the base times the height. We can be a little bit more specific with the cone. Since the base is a circle, we can say the volume is equal to 1/3 pi r squared h. And that is how Becker breaks it down.